In part B, we have f of x equals quantity x squared minus 4 to the 2/3, and we will take the first derivative so that we can find our critical values. This will give us 2/3 times x squared minus 4 to the negative 1/3, power times base down 1. Now chain rule, 2x is the derivative of x squared minus 4. And let's rewrite this. This will now become 2 times 2 is 4x on top. On the bottom we have a 3. And x squared minus 4 to the positive 1/3, that's the cube root of x squared minus 4. And let's think about our critical values. When are they going to occur? So we get critical values when the derivative is equal to 0. That's going to happen when 4x equals 0. We also get critical values when the derivative does not exist, and that happens when this is undefined, or in other words, when x squared minus 4 is equal to 0. But if we write it in such a way that the function exists, we'll make it not equal to 0. So either way, we can solve for critical values, and we get x equals 0 and x equals plus or minus 2, and we will make a number line. So we have negative 2, 0, and positive 2. And our test values can be negative 3, negative 1, positive 1, positive 3. And type this function into your calculator in y1, and then just simply substitute each one of these values into your first derivative and test them. And we get the following signs. Again, I'm not really worried about the numerical values. I just want to know if the derivative is positive, negative, or 0. So if we plug in a negative 3 into f prime of x, we do in fact get a negative derivative. Negative 1 gives us a positive derivative. Positive 1, a negative derivative. And positive 3, a positive derivative. Now what does that mean for our function f? Well, if f prime is negative, that means f is decreasing. And if f prime is positive, f is increasing. So decreasing, increasing. And let's map out those intervals now. So increasing and decreasing. So it is increasing on the interval from negative 2 to 0 and from 2 to infinity. And these are going to be open intervals. It is decreasing on the interval from negative infinity to negative 2, union 0 to 2. All right, now let's check out our maxes and mins. So we're going to have a max when we go from positive to negative, or increasing to decreasing. So that's going to be at x equals 0. And so we want to find out what f of 0 is. And f of 0 is the cube root of 16. And if you want to simplify your radicals, that's 2 cube root of 2. Our mins are going to be at, that's where we go from decreasing to increasing, and that happens twice, once at negative 2 and once at 2. And as it turns out, f of negative 2 is equal to 0, and f of 2 is also equal to 0. And so there we have our complete analysis.